So in the previous video, we seen the equation for a total axial force and torque transmitted by the T. So now we're going to consider the condition based on uniform pressure or uniform wear theory. So let us go for the first condition. So uniform pressure theory. So uniform pressure theory normally you're going to use for the new clutches. So employing the number of springs, the pressure can be assumed to be uniformly distributed over the entire surface of the area of the friction disc. So with this assumption, so you're going to assume that the pressure P regarded as a constant. So from the equation 1, if I take the P as outside, that is a constant one, 2 pi P. So integration of di by 2 to d naught by 2 into r into dr. So I'm going to get 2 by P r square by 2. So I'm going to simplify. I'm going to get the equation as FA, that is axial force, is equals to 1 by 4 pi P d naught square minus di square. So that will be the equation for axial force when I want to consider uniform pressure theory. Or I can say pressure intensity is equals to 4 into axial force divided by pi into d naught square minus di square. So if I take the equation 2, that is the torque equation, so di by 2 to d naught by 2 to integration of 2 pi mu p r square into dr. So I'm going to take mu and p outside as a constant. So when I'm going to get the overall equation as T is equals to 1 by 3 pi mu p d naught cube minus di cube. So I'm going to substitute the p value over there. So I'm going to get this equation. So the equation will be reduced to T is equals to 1 by 2 mu f into dm. So dm is nothing but the mean diameter. So that can be given by 2 by 3 d naught square minus di cube divided by d naught square minus di square. So this equation is called as the mean diameter equation. So by substituting that, the torque transmitted by n frictional surface, if the number of frictional surfaces are more, if they consider as a single frictional material but both the sides as effective, so then becomes n. So n mu f into dm by 2, or n I can also state as I also. So axial force will be equals to pi into p r square r2 square minus r1 square, that will be equals to 5 by 4 p d naught square minus di square, that is outer diameter and inner diameter. So that is about the uniform pressure theory. So where the uniform pressure theory is normally considered for the new clutches and pressure remains the same in the spring. So now coming on to the second one, the wear theory. So wear theory normally you are going to use for the worn out clutches. So you can say that it will be used for the running clutches. So according to this theory, it is assumed that the wear is uniformly distributed over the entire surface area of the friction disc. The assumption is made for the worn out clutches. So if I consider the work done by the frictional force will be mu into P and the rubbing velocity will be 2 pi r n. So where I can say that n and mu is a constant for a given condition. So the remaining thing is P into R. So the P and R is directly proportional to what is the amount of wear it going to take. So I'm going to take that wear is a constant. So I'm going to take P into R as a constant C. So when I'm going to substitute this into the equation, I'm going to get a different equation for a torque and axial force. So when the clutches are is new and rigid, the wear at the outer radius will be more, so which releases the pressure at the outer edge due to the rigid pressure plate. So this will change the pressure distribution during running condition. The pressure distribution is adjusted in such manner that the product PR is a constant. So by taking the equation now, so axial force FA is equals to 2 pi, so di to d naught, P into R into dr. So I'm going to substitute the equation. I'm going to get P FA, that is axial force, is equals to 2 pi C d naught by 2 minus d1 by 2. So if I substitute that, I can get as pi C into d naught minus d1. So C will be nothing but P into R over here. So R I can write C as a constant is equals to FA by 2 pi d naught minus di. So when you go for the torque equation, T equation, which you taken in the previous one, that is equation number 2. So I'm going to get 2 pi mu C into d naught by 2 by 8, d1 by 2 by 8. So I'm going to simplify that by substituting the C value over here. So I'm going to get a torque equation as 1 by 2 mu FA into dm. So here dm will be given by d naught plus di by 2. That will be the mean diameter in the case of the wear condition. So where dm is equals to d naught plus di by 2. So torque transmitted by the n frictional plates. So n can be replaced as I or n as it is. So it will be n mu FA into dm by 2. So again here n will be dependent on the number of effective surfaces. So average pressure occurs at the mean radius. If you consider as a mean radius, so what is the pressure I'm going to assume? So it will be FA is equals to pi into B dm d naught minus di divided by 2. That will be the axial force at the mean radius. So maximum pressure occurs at the inner radius. So when it is occurs in the inner radius, it will be having the maximum pressure. That is, axial pressure is equals to pi p di divided by 2 multiplied by d naught minus di. So the major portion of the life of the friction lining comes under the uniform wear condition. So in the design of clutches, uniform wear theory is justified. So you're going to consider normally the uniform wear theory for the calculation purpose. So coming on to the multi-plate clutches, so you can see in the diagram, so there will be number of frictional material lined up on the driving shaft. So driven shaft will be here. So driven shaft will be fixed, the flange will be fixed. So driving shaft will be carrying the number of frictional materials which will be adjusted by the lever and with the compression springs. So the housing is keyed to the driving shaft by a sunk key. The clutch shown as there are 5 pairs of frictional surfaces. The driving disc may be pressured against the driven disc by the suitable mechanism so that the torque will be transmitted by the friction between the disc. So if I take the conditions, so equation derived for the torque, so uniform pressure theory, so this is the equation I want to get. So for a uniform pressure theory, the torque will be given by half I mu Fa into dm. So I is the number of frictional materials and mu is the coefficient, Fa is the auxiliary force and dm will be the mean diameter. So dm, that is mean diameter, is given by 2 by 3 d naught cube minus di cube divided by d naught square minus di cube. Whereas for a uniform wear theory, it will be dm is equals to d naught plus di divided by 2. The auxiliary force for a uniform pressure theory, 5 by 4 p d naught square minus di square. Whereas for a uniform wear theory, it will be 1 by 2 pi into b dm multiplied by d naught minus di. So where I is the number of frictional surfaces and the maximum pressure occurs at the inner radius, that is given by Fa is equals to 1 by 2 pi p di multiplied by d naught minus di. So these are the equations which you are going to use for the calculation purpose. So coming into what are the procedure you are going to follow, the design procedure for a disc clutch. The design consideration is mainly depends on how to obtain the best balance between the maximum torsional moment capacity and effective operating life. The following information must be available. One is the torsional moment to be transmitted, the limiting dimension, the pressure required to engage the clutch plates, and single disc or a multi-disc connections. So we're going to see the procedure now. So design procedure for single plate and multi-plate clutches. The steps involved, the first step will be torque transmitted. So we're going to use the formula mt is equals to 9550 into 1000 into n by n, where n is in RPM and this n will be in kilowatts. So 1000 will be used only to convert the equation into Newton mm. So diameter of the shaft, d is equals to cube root of 16 m into t. So mt already calculated over here, you can substitute over here. Pi, tau s will be the shear stress and n will be the keyway factor. So this diameter of the shaft will be calculated when d1 and d2 are both are unknown. So this can be the shear stress can be calculated using the ultimate stress, that is the yield stress. From the yield stress you are going to calculate the stress. From the stress you are going to calculate the shear stress, and keyway factor you can get from the table. So coming to the third step, it will be mean diameter. So mean diameter will be depends on the two condition. Either it may be uniform wear condition or a uniform pressure condition. So whenever it is having a uniform wear condition, so dm, that is mean diameter, will be given by 1 by 2 d2 plus d1. For a uniform pressure condition, it will be dm is equals to 2 by 3 d2 cube minus d1 cube divided by d2 square minus d1 square. That equation will be 19.85a. The next step will be fourth step, that is axial force. We're going to calculate. Again depends on uniform wear condition and pressure condition. The equations are 19.86b and 19.83. The fifth one will be the dimension of the clutch. So this can be done again going for the MT formula, that is the torque transmitted formula, that is MT is equals to half mu Fa dm into I. So Fa already calculated in the previous step, dm will be calculated and I will be given in the problem. So you can assume I either 1 or 2 for a single or multi means, it depends on the number of plates. So I want to calculate that. So once the values has been calculated, so I can identify dm or Fa value from this. So from that I can find out the inner diameter d1, the outer diameter d2, the mean diameter dm, and thickness of the disc can be assumed between 1 to 3 mm. So that is given in equation 19.92. So I am going to assume as 2 normally. So the axial force Fa also has to be calculated. These are the steps followed to design a clutch.